Hello. So in this video, what I have done is I've created a way of transmission. I mean, it's done out there with digital signals all the time. That's basically what we transmit our voice on. They you probably use an ADD converter to turn it into a digital signal, and they transmit over a telephone line or wireless stuff like. I did that with LabVIEW, and I mean the circuit that I'm building can do this because it's a multiplexer and a demultiplexer, and I just added an encoder on here, and the encoder and decoder would have been an ADD converter and a digital analog converter, but I just kind of put it together. I put it in a program. I wrote a program to test the theory because I did use logic gates, digital gates, and I'm going to show that to you. So what you're going to see is I have an input which I'll type into it. I'll type a message, and then I'm going to that message will have a bunch of letters and characters and stuff, and these are the only things that I've encoded into it. So these binary bits will represent an A. This will be a B. This one would be the was that at I don't know what you call that, but then this one will be a lowercase t, and it just keeps going like a uppercase W. But what if this is if it receives this byte of data, this is what the output will be. What it does is this program, it will convert one character, no characters, or multiple characters into a digital signal. Send it across. It would send it across transmission line. It doesn't because I don't have transmission line, and then it decodes it on the other side. So I'll get to the program part of it now. Again, I did write this to where and I'll show you part of it. I'm not going to show you all of it. I mean, if you want to build your own mux and demux with AND gates and inverters and OR gates and stuff like that, then you can do it yourself. I had to simulate a few things like JK flip flops, stuff like that. I had to simulate it because I couldn't, you know, right. I couldn't use the gates on here to create that. But anyway, there's a step one, which is encoding and multiplexing of data. Then it will have the transmit of the multiplex data, and you'll see that it will be in binary bits instead of a message. It'll be binary bits. Then it'll receive the binary bits, and then it'll have an output string over here. And I'll show you that it actually works. I'm going to run it. I'll show you how it's working, and then I will show you how it actually works. So the first So the first thing I'm going to do is I'm going to run this thing, and there's nothing down here. There's nothing, so it shouldn't have anything. See, it didn't do anything. It ran and it stopped. I'm going to put an A in here, and you're going to see the output over here will have an A. Boom, and it has an A right here, small A. I'm going to show you. I'll have Z, uppercase Z now. I have uppercase Z. Now I'll send a message of some kind. So. 1 second, I'll try to think of something to type. I'll do something simple. Uh, 1 minute. It takes a long time to type this. Okay, I'm back. Yeah, I'm gonna transmit that message. It's only myself, so don't worry. Okay, now let's go into binary. It'll go to binary real quick. Now transmitted there, and now it's receiving on the other side. And there's the message. Now I'm going to show you it works. Now, the best way to show you that it works is by going to the blog diagram and showing you the actual program part that I can show. I don't want to show you inside of here or inside here because that's where all the AND gates and stuff are. I don't want you to steal that because you might, create something that you shouldn't create. And I don't know. I don't know what you do, but uh, this is the encoding, multiplexing of the message. This is where the transmission of it would take place, and this would be the demultiplexing and decoding of the message. This right here is the decoding of it. That's where I put all that stuff in that I was talking about right there. This stuff that I encode it and then I decode it on the other side because that's what you'd probably do with an analog digital converter and then digital analog converter. It's basically kind of taking that spot. So I'm going to show you that it works by putting probe points on here so you can see the probes. So the first probe will be right here. This would be the input. So the input would be right here. And then you'll see that it changes into a digital transmission on the output of this loop right here. So it's not X. You can see that. I'm gonna make it start. So there's the message coming in. You can see right here. It's actually that's what's being sent out to be the transmission of the message. Now it's going to be transmitted at this point, and it goes across the other side. So now I've proven that part of it is converting to binary bits. Now I'm going to show you what the transmission of the data looks like when it transmits. Again, you can see that the this part of it'll clear, but this part's not executed because I just started that probe point. So that part's it's changing again because I'm rerunning the program. It's the same message. I'm rerunning the program. Now you're going to see it will transmit the data. There goes the data. That's all the data. There's a lot of data in here. You'll see it's 8 bits wide. It's 1 byte of data, 8 bits wide, and it's a lot of data. It just keeps going. As much data as I typed. See, it's up to it's an array. It's like an array of data. It's just sending out arrays of data that I'm doing the way I'm doing it. But okay, so now you see this has been transmitted. Now I'm going to show you the receive side. The receive side's over here. So I'm going to leave this open so you can see it. That's the transmission, and then I'm going to show you the receive side. Now for the receive side, what I'm going to show you is first I have this. This will be the data coming in. It breaks it down into 1 byte of data at a time, and this reads 1 bit of data at a time because it's real time. If you're reading 1 bit and converting 1 bit at a time, sending it over here so it can be decoded. That's what multiplex. It multiplexes 1 bit at a time. It demultiplexes 1 bit at a time, and then it sends it over here and where it can be decoded. So I'll go ahead and I'll show you this part of it. This is where you'll see it'll be one. Once it gets to this part, it'll be 1 byte of data. 1 byte of data. There's 1 byte of data at a time. 1 byte at a time. 8 bits at a time. I'm almost there. It goes. And now that I've showed you that part of it, what I'm going to show you is you can see it's still right here. That's 1 byte of data at a time. Now I'm going to show you that it's actually, I'm just going to put a probe on each of these so you can see the actual bits as they're coming in. Won't hurt. I might have missed one of the data bits. I don't know. I'll go ahead and start that, and now you'll see these bits will start toggling once it gets to this part of it. And you might be saying this is, acts really slow. It's because I put some delays in here so you can see it running, so you can see it actually happening. And there it goes. Now it's on this part. It's at this part of it right here, where it's data bits. These are data bits, and now it's going to convert it. I'm going to show you that it's converting it to a string characters. So here, this is where the data bits are going into, and this is the output. And what you're going to see here is that it reads the output should be 1 character at a time, and then I'll go and start it. and then it sends it into it should be 1 byte of data at a time, and it sends it into here where it's going to so you can see it's one letter at a time. It's building the string as it's going. It's doing 1 character at a time, and then it goes into here where it builds the string. You see that it'll build the string once it gets to this point. Again, it's really fast. It's just I have delays in here so you can see it actually working. Now in software, you can do this in software really easily. Um, and the way you can do this in software really easy is you don't have to do all the AND gates and stuff. You don't have to do all that stuff. But I want to do it because it's something I'm building, something I designed myself for me to build myself. Just waiting for someone to do something. So anyway, you can see the non-executed part. You saw this one building a minute ago. You'll see it building again and the final output will be basically all that, but it just sends 1 output at one time. So the one that's not executed, once it's done, it just sends it all out at one time. Now I'm going to remove the delays, and I'm going to show you that it's almost instantaneous to us. So I'll remove the delays, and the way I'm going to do it, I'm just going to make it 0. I have another one over here. It does just a small delay. Now you'll see it runs quick. Boom, it's done. It's that fast. It's done. So now turn it over. Go to the other side. I'm going to put the. I'll just go over here, and I'll show you that it's that fast by changing this, and then I'll add that. Now you'll see that appear over here. It'll be almost instantaneous. Boom, it's over here. See, it just sends it all that quick. I could change the whole message, type a whole bunch of stuff on here, and it'll just change it all. A bunch of A's, B's, C's, D, E, F. That, and then it's instantaneous. It sends to the other side. If I put the delays in, you'll see it actually working, but you can see that it actually works. And that's basically I encoded a message, I multiplexed it, I transmitted it, I demultiplexed it, then I decoded it and displayed it where you could read it. I guess I changed my mind. What I will show you now is it is a mux and a demux. I'm going to show it to you. I don't care if you steal it. They work out 8-to-1 mux designed, and I just built it, with gates. And it works. You can build it with gates. That's a mux, 8-to-1 mux. I mean, they got a chip out there that does that, so it don't matter. I got a chip you can buy that does that, and there's the AND gates for the demux. That's it. It works. And this would be a JK flip flop. Basically, it sends 3 clocks in. One's 1 clock speed, then it has a second clock, then a third clock, and this is selector. Anybody who has a mux and a demux, they in those digital electronics, they know that. Anyway, that's what I've been working on because nobody will tell the truth.